Okay, hi, my name is Marius Kortz and I would like to present the Cityscapes dataset for semantic urban scene understanding. This is joint work by Daimler, the MPI Informatics and the TU Darmstadt. During recent years, datasets for training and benchmarking of algorithms have been a driving factor for the progress in urban scene understanding. In terms of a semantic scene understanding, however, these datasets are typically limited. In Kitty, for example, we have only bounding box annotations. In Daimler urban segmentation, the annotation density and quality is rather low. Or sometimes input data that you might need to run your method, such as stereo data, might simply be missing, for example in Cambit. Further, all these datasets have in common that they were recorded in a single city only, and that their videos stem from a few video streams, the images, and that makes them both spatially and temporally highly correlated. To overcome these limitations, we propose the Cityscapes dataset, where we aim for a new level of diversity. So what we did is to focus on complex, busy inner city scenes, and we recorded in 50 different cities all over Germany and neighboring countries, and that happened during 3 seasons from spring to fall. Also, we made sure to have sufficient multimodal input data available, such as stereo and video data, as well as vehicle odometry and GPS tracks. The core of our dataset are of course the annotations. We have 5,000 images with this type of high quality and high detailed annotations, and all this was done purely manually, there's no computer vision inside. We labeled 30 different classes out of 8 categories, and we also have instance level labels for all the dynamic classes. That means all the people and vehicles in the scene are labeled individually. Since this type of annotations, paired with a sophisticated quality control, was pretty time consuming, we also propose a second type of annotations. And this is what we call our coarse annotations. Here the idea is to maximize the number of annotated pixels per minute of annotation time. So we have 20,000 images with this type of annotations. That's, for example, useful for some kind of weekly supervised training. And these coarse polygons are required to be inside each class, and in doing so the annotated pixels are correctly annotated, but of course the density is not 100%. After having finished the dataset, we can also query for some interesting scenes. For example, in the top left we see the scene with most instances. That's simultaneously the scene with most people. There are more than 100 pedestrians on the bridge in the back of the scene. Top right shows the scene with most bicycles, bottom left the scene with most cars, or we also included a scene without a single instance. Also, after having finished the dataset, we can train some sophisticated method. We show pretty decent results already in the talks before us. This one is a result from Adelaide context on our test set, and that looks pretty impressive as well. To benchmark these methods, we have an evaluation server such that we can evaluate on a non-public test set to prevent an overfitting of the methods. We are focusing on 2 major challenges. The first one is called pixel-level semantic labeling, which is basically standard scene labeling, where the task is to assign a label to each pixel in the image. And as can be seen from the current result table, there are already all major baselines already available. The currently best performing is Adelaide context with an intersection over union score of 72%. The second challenge is called instance-level semantic labeling. Here the task is to retrieve the individual instances in the scene. We have 2 baselines available. The best one has an average precision of 9%. This comparably low score also indicates the challenges that are behind this task. Now I hope I made you curious. I would like to have a more detailed discussion at the poster. We could have a closer look at the dataset statistics, the evaluation metrics, and also the available baselines. The dataset, including the evaluation server, are already available today at our website, cityscapes-dataset.net. Please check it out, and thank you for your attention.